Weak acids and weak bases establish an equilibrium when they dissolve in water. We're going to pay attention mostly to weak acids, which when they dissolve in water, each acid molecule will react with a water molecule to form the conjugate base and a hydronium polyatomic ion. So we remember that an acid is any substance that can donate a proton, and base is any substance that can accept a proton. When we look at a weak acid in its molecular form on the reactant side, reacting with water, the weak acid is the acid and donates its proton to water. Water is the base and accepts that proton. However, on the product side, since we have an equilibrium situation, the reverse reaction is also occurring. The conjugate base of the weak acid will accept a proton from the conjugate acid of water, or hydronium, and then form the molecular form of the acid as well as a molecule of water. For weak acids, only about 5% or less of the molecules of an acid will react with water to form the conjugate base and hydronium. You will be expected to identify an acid and its conjugate base. And to do that, the acid will always have one more hydrogen, and its charge will always be greater by +1. So if we look at this molecular acid has a charge of 0, and on the product side, its conjugate base has the same formula except it is less 1 hydrogen, and its charge is more negative by 1. If we look at the conjugate acid of water, it has one more hydrogen than water does, and its charge is more positive by 1 than water is. So an acid and its conjugate base are separated by a proton, not only the hydrogen, but also the +1 charge that comes with that proton. When we write the equilibrium expression for a weak acid, the conjugate base and hydronium are always in the numerator, and the molecular acid is always in the denominator. We do not include water in the expression since it is a pure liquid.